their fifth Spark episode on February 13th with their guest speaker, and engineers. UMead has been working in DC Hydro for the past 10 years and is currently working with major electric hydro alone power for the province allocation plan for the next 20 years. She will be sharing about her interests in high school and how she turned them into careers and what she does at work now. Come to room 301 on Tuesday, February 13th to learn about her personal journey and how to pursue a career in the field of education.
Why you take road trip?
Attention Miss Meadows Semester 1 art students. Please come and collect your artwork from room 116 James Flat. Nutrition break or lunch by next week, else it will be recycled. BC Government and Services Employees Union offering scholarships for post-secondary studies undertaken by EGGEQ members, staff and their families. This will also be an additional scholarship for individual students. The deadline will be February 6th. Middle and year mathematics were recognized for their year commitment of further studies in mathematics by a single student demonstrating in mathematics and academic excellence. More broadly, the deadline will be February 15th. For more information, go to the scholarship and see Ms. Saleha in room 301. Diversity Dance 2024. Attention all students. On Wednesday, March 6th, Burnaby School District will be hosting our annual District Diversity Dance. This dance is open to all high school students in the Burnaby School District.
How
in
is
the
our
spirit of
sports day
celebrating
during
the
first and
diversity
second?
and inclusivity of students.
thinking
That's a good
about the quiz.
question. That's a good question. I'll check. Yeah, that's a good point.
Provide us early to avoid missing out. The theme of the dance is Enchanted Forest, so wear your best themed outfit. To see you all there. Thank you, coming there.
Hi. I did not check my email this morning.
Oh,
Sorry.
okay. So she was pretty much saying like she's in this big work conference. She
Okay.
currently works at home.
Yeah.
My brother's working, and I'm volunteering at lunch. So she's like, I need you to go home and let like my dog out.
Okay.
So it's like health issues. It's
No
like,
problem.
you like
Yeah.
So I have to leave like 10, 15 minutes early.
No problem.
Okay.
Yeah.
Because normally at the time we're doing work anyway.
Yeah, usually. Yeah. Okay, I'm not seeing any information about Mountain Madness here. Let me just ask next door.
I had an app for a bit, right? I paid for a few months and I just lost the ball. Oh, I didn't lose the ball. I just got a little battered. Well, you can see it, the layer. It's like a new layer. But I got battered. It was really good. Yeah, but like, what's the point, bro? Living life, you're not gonna go through it, bro. Might as well eat it.
For your information, Mountain Madness is taking place for grade 11. That would be tomorrow in the afternoon. And if you are participating in it, you do need to have a field trip form. Okay, so that does not affect our block at all, unless you're in grade 10, in which case you might need to come talk to me just to let me know what's going on, and we can make an arrangement for you for the quiz, because tomorrow we have a quiz, and I'll make sure that all of this is up on Teams, although it sort of is already, just worded a little bit differently. You need to be able to go from scientific notation to standard notation. You need to go back from standard notation to scientific notation. You need to recognize no notation. I guess I should write that. Recognize when you are not in scientific notation. You need to be able to keep your sig figs consistent when changing the notation from one form to another. You need to be able to use an overbar when necessary. You need to know what the overbar means. And like I said, you need to recognize when you are not in scientific notation. Is there anything up here where you're like, what does that mean? That you would like me to just have a brief review on or anything like that? Yes, no, that was just an arm. Okay, never mind. Yes.
The overbar?
The overbar. I was wondering if anyone was going to ask about that. Are you guys glad this guy asked about that? Yes. You see what it's like? People want to know about things, and if you don't ask, and you're not lucky enough to have someone else who asks, then you might just sit there and be like, oh, I'd like to know what the overbar means, but I'm too shy to ask. Actually, I had a really good talk with my Chem 12s yesterday, and we talked about just being sort of a little bit more open in class because they don't actually answer any questions. When I ask them questions, they just sit there and they stare at me, right? You know, how do I convert from moles to grams? Right? And I told them it's a bit like a conversation. We want to be having a conversation. If I was to walk up to you and say, good morning, how are you? And you just stared at me, maybe with a smile on your face, maybe not, then that's a little bit weird, yes? And what if I were, you know, what if you went to Home Depot and you're trying to find something at Home Depot, right? And there's like, how many aisles? Like 47 aisles or 65 aisles or something, and you're trying to find it? Do you actually wander through the whole store, up and down every aisle, trying to find it? Or would it make more sense to ask the person with the little Home Depot badge to say, what aisle would I find toilet plungers in? You'd rather walk through the aisles, and you know what? God bless you. If you are willing to go through all the work on your own, then that would be like walking through all the aisles. Okay, so if you're willing to do all the practice, and if you are willing to read the answer key and check all your answers, then that would be kind of like wandering through the aisles. I'm just going to come up here so I can see people at the back because I never get to see you because I'm too short. Okay. So yeah, I mean, there is a way of doing that. It does take you longer, right? But it would make more sense to go and ask the guy, hey, where would I find a toilet plunger? And he says, aisle 20. And then you're in and out of the store in no time flat. And you're like, wow, that was easy. I found out where the toilet plunger was. Yes? Anyway, that was my kind of public service announcement for the day. So let's talk about the overbar. So if you need some paper, feel free to go help yourself to some paper. An overbar is used over top of a zero. It's not used over any other number. And it is used when you are writing in standard notation. And it needs to be used, it's only used for big numbers, numbers greater than 1. And what it is when the last zero is not the uncertain digit. So let's say I wanted you to write this number with 3 sig figs, but keep it in standard notation. So I still need to have it in standard notation. So it still looks like this. Yes? What an overbar does is if you put it here, it indicates that that is the uncertain digit. It indicates that that is your last significant figure. So that's what an overbar means. It means that is your last significant figure, that is your last uncertain digit. So I could write 46,000 with 4 sig figs. Tell your partner what that would look like with 4 sig figs still in standard notation. We would say we want 1, 2, 3, 4 sig figs. So our last sig fig is here, but because there's no decimal in the number, and I can't put a decimal in the number because if I did, it would be over here, and that would tell me then that I had 6 sig figs, yes? Okay, and I don't want that, I want 4 sig figs. So really the only way to do that is to go 1, 2, 3, 4, there is my last sig fig. Okay? And the reason that this comes into play is that I might have something like 2.570 times 10 to the 5. And let's write that in standard notation. Okay, just for practice, see if you can change that into standard notation and then see if you can indicate the correct number of sig figs. If you've forgotten scientific notation, what does the 5 tell us? It tells us it tells you that it's 100,000. It tells you to move the decimal place 5 places. Okay, you're multiplying by 100,000. So you move the decimal 5 places. Now, because that is a positive number, does that mean we need to make the number bigger, or do we need to make that coefficient part bigger or smaller? We need to make it bigger. So we move the decimal to make the number bigger. Okay? So we are going to move that decimal place 5 places. So I have 2.570. That's going to move 1, 2, 3, 4, 5 places. I'm going to make sure I put some zeros in there. So that becomes then 257,000. But whenever you change, you're going to want to do it to the same significant figures. How many sig figs in this number here? 4 sig figs. So we need to have 1, 2, 3, 4 sig figs here. How are we going to do that in standard notation? We're going to use that overbar, okay? So that's how you would use it going from scientific to standard notation. Now let's go the other way. Let's now change that into scientific notation. So to change into scientific notation, you need to move the decimal until what? Tell your partner, until what? We need to move the decimal until there is only one non-zero, zero digit where? In front of the decimal. So we're going to move our decimal. Here it goes. 1, 2, 3, 4, 5. So that's going to be 4.37. I'm going to write the times 10 to the 5 over here. Now, do I want that to be a positive 5 or a negative 5? I want it to be a positive 5 because this is a big number, bigger than 1. And therefore, this needs to be a positive exponent. Okay? Now, would it be okay if I just wrote 4.37 times 10 to the 5? No, because I have this overbar. What does that overbar tell us? That's the last sig fig. So we say my last sig fig is over here. So that's going to be 1, 2, 3, 4, 5 digits. So I need to go 1, 2, 3, 4, 5. Is good? Okay. Should I write the number 237,000 with an overbar over the 7 to show that I have 3 sig figs? No, because I don't need it, right? Because that 7 is already significant. Oh. Oh, look, it's entitled Likely Fraud. Literally, that's what it says, likely fraud. Okay. Anyway. So we know the 7 is significant because it's a non-zero digit. Should I write? .800 overbar to show 4 sig figs? No, because that 0 is already significant because there is a decimal in the number. That's a T, in case anyone's wondering. Okay, how are we feeling about that? Overbar is good? Okay. By the way, if any of you are like, I took physics and this is really boring for me because I've already done this, and you would like something extra, if you're like, oh, I would like to learn something extra, I can find you some of my Chemistry 11 enriched stuff, and you can maybe learn about like orbital shapes and orbital diagrams and some interesting things like that. It is an option for you. If you would like that, let me know. I'll have to run stuff off for you, but I definitely can do that. So if you're just sitting around bored out of your tree, let me know. I can find you things, okay? It won't you can work on it. I can give you a quiz on it if you would like. It won't count for you or it won't count against you, okay? All right. So last night you were to have read some stuff about homogeneous and heterogeneous mixtures. I would like you to draw a picture, please. Draw 2 pictures. One of a homogeneous mixture and one of a heterogeneous mixture. Give that a go. Get yourself a piece of paper, draw a homogeneous mixture, draw a heterogeneous mixture. Now, if you have to go looking one up, I want you to think to yourself, A, did I do the homework? B, if I did the homework and I don't know, then I need to start asking more questions when I do the homework. Because if I manage to read that entire thing and do all the questions and I cannot the next day draw a picture of homogeneous and heterogeneous, then I need to start asking more questions as I go through it, right? Because then I'm obviously just not quite understanding yet, okay? Now, if you're away, don't worry about it. You're good. Out of the two pictures that I have drawn here, which one is heterogeneous and which one is homogeneous? You've just got it backwards. That's all, okay? The first one is heterogeneous. Now, do you guys know what the prefix hetero means? So if someone is a heterosexual, they are attracted to people of the different sex, okay? So hetero means different. Okay? The prefix homogeneous. Prefix homo means the same, because if you are homosexual, you are attracted to people of the same sex. Yes? Also, if you've ever heard, do you know what the species is for human beings? Homo sapiens. That because it means they are, like, Homo sapiens are all the same as us, the people who came up with the word Homo sapiens. Yeah? So it means same. Same as us. Okay? Now, what I want you to notice here is that in this picture, do you see how we have clumps? Do you guys know what a clump is? Okay, that is a clump of red atoms. Are they mixed evenly with the white atoms? No. So what we have is we have different areas. And those different areas will have different properties, okay? So let's just say that the red atoms were copper atoms, okay? They would have the properties of copper. They would be copper colored, yes? But let's say that the white atoms were silver. They would have the properties of silver. They would be silver colored, okay? So let's just say that these guys here are copper and that these guys here are silver. And so you would have copper properties where you have the copper. You would have silver properties where you have the silver. The key thing that you are looking for is you are looking for clumps. Yes, for heterogeneous, look for clumps of a particular type of particle. That's your clue. If you have a heterogeneous mixture, you have a clump. You have at least one clump, probably more than one clump. Okay? Homogeneous, it should be all the same throughout. Now, you have to imagine when you zoom in so close, it might not look like a completely even distribution. But if you multiplied that out by millions and billions of times, would that distribution be even and random? Yes. Okay. So there should be an even, random distribution of the different types of particles. In other words, if I was to take a sample from over here, and I took a sample from over here, the composition of those two samples would be approximately identical. Okay? This is sample A. This is sample B. In a homogeneous mixture, the composition of sample A and sample B should be identical. Whoops, not by, should be approximately identical. The reason I only say approximately is because when we draw such a small sample of atoms, right, in that drawing, I only really have 1, 2, 3, 4, 5, 6, 7. I only really have about 20 atoms. It's hard to show a really true even distribution when you have only 20 atoms. You would need like billions and trillions of atoms to show real random distribution. Okay? So how are we feeling about homogeneous and heterogeneous? A little bit better? Okay. What is another word for a heterogeneous mixture? Mechanical mixture. So it is also known as a mechanical mixture. And a homogeneous mixture is also known as, just in case you didn't know what AKA stands for, it stands for also known as
A solution.
a solution. And I would like to give you guys a little time to work on some stuff today. So if you would like to, where did I put those extra ones? Okay. Because you got your quiz on scientific notation tomorrow. If you've not yet done page 117, do page 117. You could also do page 113, number 37 and 38. And the second thing I would like you to do is, where is it? Dun, 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 dun. Dun, 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 dun. Page 50, 51, 52, 53. Pages 50 to 53. Okay. And if you were away or you didn't do last night's homework, then you should also, if not yet completed, you would want to do, where did it go? Pages 54 to 58. But hopefully those are done already because that was yesterday's homework, 54 to 58. But if you were away, you might not have had a chance to do that yet, okay? Pardon me? Oh, you want me to go up? Yeah. Like that? Yeah, no worries. I'll turn the lights down a little bit so you can see a little bit better too.
Thanks, Chrissy.
We're getting close now that we've learned about homogeneous and heterogeneous mixtures. We're just about ready to do our lab. We'll be doing a lab next week. Yay! About time, right? Oh, you're gonna say this in scientific or not in science. Okay, so first you need to answer is in science. You really need to move this decimal here. Yeah. And so it's not 5 times 4. I'm sorry, not 5. It's not scientific. So you will change it over here, we want the number and such. I'm gonna add one on here. This is 5. Okay. So this one is not designed to go here, this one is designed to go with something like a field. Yeah. Yeah. You still want that one, you just count it as 1.5 part. Oh, and if you missed page 16, 116, make sure you've also done 116. If not yet done yet, page 116. There we go. It's your grade 10, yes. So I believe that you are in the morning tomorrow, so you will miss this class, which is totally fine. You could either wait for this tomorrow class, or you could wait for Friday. That sounds good to me. Yeah, thank you. No problem. Any other grade 10s? I'm not gonna really work in this slide here. You first answer whether they are. And then we're going to rewrite after those signs. Yeah, that is. I'm just gonna go for it. Sorry to keep you waiting. I probably won't have to define it. See if you can make sure it's together. Like what is true about it? Beautiful. That's what we need to say. That's a compound. Two elements bonded together. Done. So an element is just one type of atom. Okay, so if you have two atoms but they're the same, that's an element. If you have two atoms that are different, that's a compound. So elements, the atoms are the same. Compounds, the elements are, or the atoms are different. So this one, we got a nitrogen. Same. So all the oxygen and oxygen are the same. Compound, we have oxygen and oxygen. We also have carbon, so the elements are different, so that makes it. Yeah. And If your car is here, you want to turn your wheels so that you start to roll this way. Yeah. Right? If it's pushing down, you know, we want to know so it starts to roll a little bit. You don't ever want to roll in the it's like a parallel park, but you just make sure it's on the end. Easier said than done. I got it, but anyway. Okay, so this one. I don't really know. I'll give you. If you don't, you're sitting in the right, you can in your car. Are you? Ladies and gentlemen, on page 117, I think it's number 2 O&P, is it? Hang on one second, sorry. I got to give you the number as well. Yeah, number 2 O&P. Number 2 O&P, the answer key is wrong. Just cross them out. Just omit number 2 O&P on page 117. Okay? Did everyone get that? What are we omitting? Nope. Okay. Hello. What page are we omitting something on? Page 117. Which question are we omitting something on? Number 2. Which parts of number 2 are we omitting? O and P. Excellent. 117, number 2, O and P. Cross them out. Because the answer key is wrong, and there's no point in having questions with the wrong answer keys.
Oh my god.
On science communication. So let's just see what we've got so far. No, that's okay. No, not that. Right, that's why I'm like, even though everyone all matters, all matter. That's why I'm not good? All right. Okay, so this is like that's okay. So you know, you're good on that. So you're like, okay, I want 5 to be in front of the decimal. So you are going to move your decimal so that 5 is moved in front of the decimal. Also good. Okay. Now, instead of overbar you side. So this number this is smaller by 1 power. Whatever you do with this, you can opt to power. That over there. Yes. Oh, yeah. Standard is just like these ones that don't have the power of 10, yeah, so you're going back. Okay? Just like if I didn't remember without the times 10 to the left. Are you going to second?
Yeah.
And you did one. Yes.
No way.
I know, I have my semester, right? Like recordings, and now he's famous, right? Yeah, I don't know. I also have.
Driving home.
Yes. I'm not looking at honestly,
Oh, so you need to go, yeah, sure. Go. Yeah.
Normal life, I think it's like all year.
It's possible. I agree. So if I like this month, exactly.
Yeah.
I know.
I know, so they're but you know, I still have to do it. No. You're in the beginning. I'm like, so it's not in the middle. So like, it's not next week, but like early week after. Okay. Yeah, I think. Yeah, that'll be it. Yeah. Well, then even for these, there will be some of them. Okay. Always. Oh, you're gonna be like, whoa. Because it's a 2-year course. A 2-year course? Right, because it's kind of not an imagine until they begin to hold material from the years. This is their multiple choice review.
How can we learn 2 years of this? And then they have like a big final one?
Well, they're right there April exam in May.
Oh, yeah.
So they're going through this to figure out what they can do on. Right, and this is like,
Hey,
right?
Yeah.
It's crazy. It's crazy.
Alright, so tell me it again. I was like, no, I really don't.
It's actually like, if you have that drive, you'll get such a good, like, better for your, so you're like, I want to go to this. Know this is like passionate about, it will really help. Yeah. Or I just, you know, I'm not gonna go and be a scientist.
Yeah.
You know, maybe I'll do that lab or something.
Yeah.
But I don't need to be like.
That's right. Extra stuff we should run soccer.
Yeah, okay. I won't have it. Maybe I'll come out here. Okay.